we're talking about today are similarity transformations, and just a reminder that when figures are similar, the angles are congruent and the sides are proportional. But a similarity transformation is any combination of rigid motions, translations, reflections, rotations, with a dilation. So that's what I want to specify especially. Whenever you have a dilation as a transformation, your resulting image is always similar. So I'm not a big underliner or highlighter, but if you have dilation, the resulting image is going to be similar to the pre-image. The image and the pre-image will be similar. In contrast, if you don't have a dilation, if we just translate, we move it right, left, up, or down, we reflect it somehow, we rotate it somehow, no dilation, then we're going to get congruent figures. And again, not a super big fan of underlining or highlighting, but sometimes the key concepts get lost in the words. Again, no dilation, congruent. Dilation, similar. So maybe we can come up with some sort of memory technique to help us remember, because the OST loves doing rigid motions on the test, and they love doing the similarity as well. And we have some OST questions actually in these notes here later on. But it says, graph the image of the figures below using the given transformations. And remember, we go in order. So the first one says a dilation with the scale factor of 2. So if we take a closer look here, our A has an ordered pair of 1, 2, 3, negative 4, 4. And our point B still has a point of negative 4, negative 3. And C has 4, negative 3 for our order pairs. And the first thing that we're going to do is we're going to dilate. We're going to make this figure bigger because the scale factor is 2. And consequently, what that means for us is that we're going to multiply every value in these order pairs by 2. So our new value is going to become negative 8, 8. We multiplied negative 4 times 2. 4 times 2. Our new B is going to be negative 8, negative 6. Again, we multiplied negative 4 times 2. Negative 3 times 2. And our new C value is 8 and negative 6. Again, we multiplied both of those values in the order pair by 2 because that was our scale factor. And that's going to be the first thing that happens. But realistically, all that we need to do to finish this is now we need to rotate that by a factor, the 90 degrees counterclockwise. So I don't know how much I can scoot over here, but I need a little bit more space. Because when we when we rotate 90 degrees counterclockwise, what's going to happen is that we're going to flip and we're going to change the first sign. So we're going to flip, it's going to be 8, negative 8, and we're going to change the first sign. And we're going to flip. So now point B is going to be negative 6, negative 8, but we're going to change the first sign. So it's really going to be positive 6, negative 8. And we're going to flip and change the first sign. So negative 6, 8 is going to become positive 6, 8. And now what we can do is we can rotate this after the dilation. Again, go in order. But negative 8, 8, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Here's our new A. And our new B is going to be 6, negative 8. Here's our new B. And our new C is going to be 6, positive 8. 1, 2, 3, 4, 5, 6, 7, 8. And there's our new C. And sorry for the little bit of disorientation, but you get the idea, and we've got the ordered pairs over there. But maybe what's more important on these is the question after the fact. The question after the fact says, are the pre-image, which is the black triangle in there, and our image, the blue triangle, similar or congruent? And again, that goes back up what's at the top of your paper here that we underline. If we have a dilation, the resulting image is always similar. And the way that we can explain that is they're similar. And even though it's not good to start with the word because, it's because a dilation, and I actually don't need a comma there, now that I think about it, because a dilation changes the size of the pre-image. If the size changes, then the figures are similar. So let's try another one. A translation, right 2 and down 4, followed by a dilation with a scale factor of 1/2. Let's move this triangle here, right 2 and down 4 for starters. Go in order of the list of the transformations. So A, we're going to go right 2. In fact, I'm going to make this a little bit bigger. Right 2. 1, 2, and down 4. 1, 2, 3, 4. There's our new A for now. B, right 2, and down 4. 1, 2, 3, 4. There's our new B. And C is right 2, down 4. There's our new C. Just as an aside here, I know it doesn't ask anything about that, but if we were to write a rule where it says translating right 2 and down 4, what we would say is we would say x, y maps to, and then right 2 means that we would add 2 to whatever x value we have, not a, don't close that parentheses there. And then for y, we went down 4, so we would subtract 4 from whatever y value we had. That's just something that we maybe didn't talk about enough in the last unit, so I'm just showing you again. But back to this problem, we've done the right 2 and the down 4, and now we want to dilate that pinkish purple triangle by a scale factor of 1/2. So our ordered pairs for our new A is -2, 0. And our new B is -2, 1, 2, 3, 4, 5, 6, 7. Is that what you got? Thank you, -7, if I write it correctly. And C is 1, 2, 3, 4, 5, 6, and -7. So here's our figure, and again what we're going to do is we're going to dilate this. And that's going to mean for us that we are going to make it smaller in this case. But we're going to multiply every value in these ordered pairs by 1/2. And half of -2 is -1. Half of 0 is 0. Half of -2 is -1. Half of -7 is -3.5. Don't forget to use Desmos if you need to multiply these and you can't without the help of a calculator of some sort. And half of 6 is 3, and half of -7 is -3.5. And now that we've dilated that, we're going to draw the picture. So -1, 0 is our final value of A. -1, -3.5. 1, 2, 3.5 is our new B. And 3, 3.5. 1, 2, 3, 1, 2, 3.5. There's our new C. And there's our final picture. And once again, what I want to stress, when we answer the final question here, is are the pre-image and image similar or congruent? And the fact that we dilated something means it's similar. And I want to look back up here at my words because I like them from the last one. Because a dilation changes the size of the pre-image. Because dilation changes the size of the pre-image. In other words, when the size changes, it's not congruent. It's similar. And now that we say those words out, that might be something to help you remember. Size starts with S. Similar starts with S. If the size changes, it's similar. Letter C. A reflection over the line y equals x, followed by a translation of left 6 units, then up 4 units. And it's always good to practice this reflection over the line y equals x. And once again, the line y equals x. It starts at the lower left corner, finishes at the upper right corner, and it goes through 0. It's really a line with the slope of 1/1, and the y-intercept of 0. I've started changing up and just putting all of the points on that line. Whatever works for you. But what we're going to do is we're going to reflect this over the line y equals x. So when we start with point A and we count, then we're going to be counting one, two, try this again. 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to go right angle. So 1, 2, 3, 4, 5, 6, 7, 8. There's our new A. We have to go across that green line. B, luckily enough, is only one space away from that green. So we're going to turn the right angle, and here's B. And see if we count 1, 2, 3, 4, 5, 6, 7. And then we're going to make a right angle. 1, 2, 3, 4, 5, 6, 7. There's our new C. So now we reflected that graph over the line y equals x. And then we're going to move this graph left 6 and up 4. So A, 1, 2, 3, 4, 5, 6, left, and 1, 2, 3, 4. There's our new A. Left 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And point C. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And here was our new B, and here was our new C. On this one, again, maybe the bottom question is the most important. Are the image, the pre-image, and the image similar or congruent? Well, remember, dilations means that the size changes, and size starts with S and similar starts with S. But in this particular problem, we didn't have any size change. These figures are going to be congruent. What happens is that the translation and a reflection only change location, not size. Translation and a reflection only change location, not size. Again, maybe a good memory technique. Similar starts with S, size starts with S. If we change the size, then the figures are similar. But the last 3 questions here on our notes happen to be former OST questions. And even though they were former, it wouldn't surprise me if they showed up again. But example 2 should be very quick. It says, Sam performed a transformation that resulted in a pre-image and an image being similar. Which of the following transformations were performed? Well, rotation changes location. Translation changes location. Reflection changes location. Dilation changes size. Size, similar. Former OST question, hopefully it should be a quick 30 seconds or less, and move on to the next one. On example 3 here, I've got a couple of typos. This should be a dot here. I'm going to make it in black. For a multiplication symbol, and that one as well. And triangle ABC was transformed to produce triangle PQR by a dilation with a scale factor of 3. Again, I need to stress that word dilation. It says select all, let's see, I forgot that word, select all of the following statements that are true. Well, remember here that triangle ABC was produced to form triangle PQR A and P are in the first position listed. So they're going to go together. So it says measure of angle A is 3 times measure of angle P. We're transforming A to get P. So in this first one, we're not going to multiply 3 times the angle P. We would multiply 3 times the angle A. And we don't have that option in this one that I see. On letter B, it says PQ, which are the first 2 values in here, are congruent to AB. Well, if we transform those by a dilation, and PQ is going to be bigger than AB, because we're enlarging, we're changing the size. So it's not B. Letter C. AB is 3 times PQ. Again, I think it should be the other way around. If we multiplied segment AB by 3, we would get PQ because we're dilating. So maybe there, then that gives us this answer D. Letter E. PQ, segment PQ, is parallel. Remember that symbol right here is parallel to AB. And again, PQ and AB are in the same position in the listing of the triangle, and we know that that is a true statement. And finally, measure of angle A is congruent to measure of angle P. Again, when they're similar, the angles stay the same. It's the sides that become proportional. So we get letter F. And lastly here, triangle ABC is transformed to produce triangle XYZ. Select all the transformations that would guarantee that triangle ABC and XYZ are congruent. Well, first thing that I notice here is any place where there's a dilation, I'm getting rid of. Because dilation means not congruent. And consequently, once we take those out, we're left with C and D and F.